Right, today we move to the last chapter for step 2. So for step 2, the last chapter is the hypothesis test by using discrete variables. Right, so the procedure to use a discrete test variable in the hypothesis test is similar to the Z test. Okay, so same things. Before you start to do the test, you need to define your variables, your parameters, okay? And or maybe after or before you need to set your hypothesis, the null hypothesis and the alternative hypothesis. And for last chapters, once you have done this, you will go in to find the Z value, right? But for these chapters, because this is a discrete test, right, and you will need to find, no longer finding the Z value, you will need to find the probability, okay? You need to find the probability in order to determine we're going to reject H0 or H1, okay? So same things, if you want to find the probability and the direction of calculation a little bit different. You see, because let's say this is your discrete data, you know that discrete data, okay, is not connected. It's not connected. So if you want to find the critical region, last chapters we calculate normally you will see the value reference to the center. But now, when we want to calculate the probability for the discrete variables, we always from the lower end and or from the upper end. So we need to calculate from the two endpoints, right? So this is the things that a little bit difference. So for these chapters, we always use the probability to compare, right? So important is find the probability. So we always consider from the endpoint. Okay, so depends on the values that given to you. Okay, if they want to test the lower part, let's say this is the x that they're given, so you need to find the probability from here all the way to the endpoint, the probability. Okay, and depends on if you want to test the upper side, same things, you need to find the probability for the upper part, okay, from the values that given until the last point to the upper part. Okay, so same things, you will need to see the keywords, okay, and if the keywords will be improved, increase, okay, so you will have upper tails, you will test the upper tails. If the question give you decrease, reduce, okay, you will need to test the lower side, so you will need to test the lower tails. Same things, if the question say that, okay, any difference, any changes, so the question may ask you to test the upper and lower tail, then we consider two tails. So the basic principle is similar to previous chapters, just this one you need to calculate the probability for the end that you need to test. Okay, so normally, okay, the step will be longer for this type of question. Okay, so discrete test in your syllabus, okay, for step 2 you only have two. One is binomial, okay, another one is Poisson, correct? So you only have two. Okay, if the third one the question did not indicate what kind of distributions, and you don't have the criteria to determine what kind of distribution, you may need to apply CLT if the n is larger or equal to 30. So so the step 2, the not difficult part, the tricking part is how you determine what kind of distribution in your questions. So not always the question will give lah, but CIE standard normally they won't put a lot of confusion on the what kind of distribution, but we don't know what kind of question will come out in your real exam. So prepare for yourself to analyze the question properly, what kind of distribution in the questions. Okay, so now we go for question 1 to see how to use the discrete variables to do the hypothesis test. Okay, question 1. Okay, we see a particular type of tomato seeds has a germination rate of 72%. Okay, in order to improve the germination rate, a manufacturer use a new treatment after which 14 seeds germinate in a pack of 15 seeds. Stating a suitable not an alternative hypothesis, test at 10% of a significant level whether the germination rate has improved following a new treatment. Okay, so for this question, same things, you need to verify what kind of distributions. Okay, so you have 15 and they give you the percentage, most probably, okay, this one will be the binomial. Okay, this is a binomial, and 72% you can say, actually you can direct state that, okay, 15 and 0.72 the success rate. Okay, so this is the parameter that you need to set. Once you set a parameter, you may start to do the test for question 1. Okay, so the hypothesis. Okay, so for binomial, you will test the P. Okay, and the question tests whether the rate has improved or not. Improved means P larger than 0.72. Okay, so this is a hypothesis that you need to test. Okay, so in order to improve the germination rate, a manufacturer use a new treatment after which 14 seeds germinate. Okay, so this is the data that you get from the after the new treatment. Okay, so 14 will be your test value. So if you want to test this question, don't forget what you need to do. This is larger. Larger means you need to test the upper side, right? You need to test the upper side. Okay, so upper side means P. You need to find the probability of P x larger or equal to 14. Right, so you found 14, so 14 must be included in your testing region. Okay, so what you need to find is Px larger equal to 14. Right, now we consider to proceed to find the Px larger equal to 14. So means you have Px equal to 14 and Px equal to 15. Right, you see you only need 2 steps to find the probability. So normally in 2 steps we don't consider doing approximation for this kind of question. Okay, so because the original distribution will be more accurate, right? So any approximation is approximate value, is not the accurate value. So you need to find this. So you have a 15C14, okay, times 0.7214. Okay, then times 0.281. Okay, and plus, not enough space, then plus 15C15, then 0.7215, then the one 0.28 is power of 0. Right, so you can find this plus together directly, and you should get 0.04950. Okay, so this 0.04950 0.4950 is represent which area? Okay, so now we see I actually don't need to draw, I just roughly draw. Okay, this is the distribution. So let's say this is the distributions. Okay, so from 14 to 15, the distribution, if you plus together, is 0.4950. Okay, the probability, the area. So now the question is asked you to test 10%. Remember that the 10% should calculate from the end part. So 10% means the probability is 0.1, right? So your probability of 0.1, use another color. Okay, means from the endpoint, your testing region is, this region is 0.1. Okay, if everything that inside this 0.1, this is 0.0495. Okay, so if everything that you calculate inside this 0.1 means this is inside the critical region, right? If you have something that larger than 0.1, okay, it's not in the critical region anymore. So this is a different compared to that test. Be careful a bit. So you can see the area that you want to test 10%. 10% means 0.1. Means the area is 0.1. The total probability is 0.1. Right? And that's how you calculate px larger or equal to 14 is 0.0495. Right? So this 0.04950 is smaller than 0.1. Right? So means 14 is inside the critical region, right? Right. So the value is inside the critical region, right? So what means when you inside the critical region means reject H not. You see the rules is the same. Inside the critical region, you will be rejected H naught, and in favor of H1. Okay, so in favor of H1 means at 10% or significant level, the claims that the germination rate has increased is supported. Okay, so you can say the claims that the germination rate has increased is supported at 10% significant level, right? So this is for question 1. Okay, now we proceed to question 2. Okay, for question 2, Isaac claims that 30% of cars in his tiles are red, and his friend Hardeep thinks that the proportion is less than 30%. Okay, the boys decided to test Isaac's claims at 5% significant level and found that 2 cars out of random sample of 18 were red. Carry out the hypothesis test and state your conclusion. Okay, so for this question, you may set your hypothesis, your parameter first. Binomial, you have 18, okay, red may be 0.3. And your hypothesis smaller than 0.3. Alright, why smaller? Because his friends thinks that the probability is less than, so smaller than 0.3. Okay, so once you have this, okay, you see the symbol here, smaller means you need to test the lower tail, smaller lower tails. Okay, and the test value will be 2 because you found 2 cars. Okay, so remember that for this you need to test the lower zone, the full zone. So what you need to do is finding the probability of p x smaller and equal to 2, right? Because you need to test the full zone, right? You need to know the probability for this full zone. Okay, so now if you want to find this is equal to p x equal to 0 plus px equal to 1 and plus px equal to 2, right? The full zone, right? And you can calculate this, expand this one equal to parameter is 18 0. Okay, so 0.7 power 18, and this one's in B5 in C1 is 18, 0.3, this one is plus, plus, okay, 0.7 power 17, okay, and plus one more, plus 18 to 0.3 2 and 0.7 16. Okay, all these plus together, you should get the probability of x smaller equal to 2 is equal to 0.0599. Okay, so you need to test 5% of significant level. Okay, now you compare to 5%. 5% is 0.05, right? So this is larger than 0.05. Okay, so larger than 0.05 means let's say you need to calculate here the lower part. Okay, 0.05 maybe is here, this area, and now you have 0.06, so it's out of this area, it's out of the critical region already. So if you out of the critical region, remember calculate from here. Okay, if you out of the critical region already, means what? Means you will reject H1, right? Reject H1 in favor of H0. Okay, because out of the critical region already. Okay, so this is a general statement. So you need to set a final conclusion. Okay, a test conclusion to test Isaac Cram at 5%. Okay, you can say that his friends Hadid's claims that thinks that the proportion is less than 30% is not supported. Okay. Right. So this is the things, right? This one, the second question, right? So for question six, second question, remember that we calculate the rejection level from the end part. So compared to the value, the probability that you find, you see is it inside the critical region or not. If inside the critical region, the probability, then you reject H0. If out of the critical region, means you accept H0. Okay, as simple like that. But so for this kind of question, you always need to find the probability. Okay, right. Now we move to question 3. Okay, question 3. In last year elections, the Purple Party gained 35% of votes. Before this year, the election, a researcher was asked to test whether support for a Purple Party had changed. She interviewed 12 voters selected at random, and one voter said that he would vote for the Purple Party. Test at 10% significant level whether support for the Purple Party has changed, and second, find the critical region for the test. Okay, so question 5 point, question 3. Okay, uh, what they want you to do. Okay, you need to look for the keywords that mentioned in the question 3. So what you to test is the support for purple party had changed or not. Had changed. Okay, so had changed means is a two-tail test. Two-tail test. So now we set the parameter. So binomial. Okay, you have 12 waters, and the probability that you select 12, the party is 0.35. Okay, this is the benchmark, and you need to set your hypothesis. Okay, and H naught is this H1 will be had changed or not, so equal or not equal to 0.35. Okay, so this question the keywords is there. So once you have this you can test as 10% of significant level already. Okay, so now this is a two-tail test. Okay, but the file value is how much? Is 1. 1 water will work for the purple party. So now what you need to test for, you want to test for the upper part or you want to test for the lower part. Right, so how we look at this, because you get the what you found is 1. If you have 12 waters divided by 2, 1 is at the lower part, right? Okay, the upper part will be maybe start from 7, 8, 9. Okay, upper part. The lower part will be maybe start from 5, or is the lower part. Okay, so for this, x is at the lower end. We will test the lower end. Okay, so you need to find px equal to 0 and x equal to 1. Okay, and if you expand this one equal to 0.65 power 12 and plus 12 0.35 and 0.65 power 11. Okay, so after you calculate this, you should get px model equal to 1 is equal to 0.0424. Okay, now you compare to the 10% significant level. Okay, because this is a two-tail test, so mean each end will be 5%. Okay, so now we consider lower end will be another 5%. So you compare to 0.05. So 0.0424 is less than 0.05. So means what? Means this value is inside the critical region. So if inside the critical region means reject H naught in favor of H1, right? Because in the critical region, right? So once you have this general statement, you can say that in favor of H1 means the support for at 10% significant level, the support for purple party has changed, is supported. Okay, you can say at 10% significant level, the claims that the support for the purple party has changed is supported. Okay, so this is for part 1. Part 2, find the critical region for the test. Okay, find the critical region for the test. So in order to find the critical region, you need to, you see this testing is a two-tail test, right? Had changed or not. So means if this question asks you to find the critical region, you have two critical region, two side, two end. So for this question, you have no choice. if you want to find the critical region, it's not like the previous chapter. You can use a Z and direct find the Z value and find the X value indirectly. But for this question, you have no choice. You need to test the values one by one in order to find the last X value that not in the critical region. So how to do that? Okay, now we consider the lower part first, the lower end. Okay, just now we know that Px smaller or equal to 1 is in the critical region. Right, just now Px smaller or equal to 1 is equal to 0.0424. Okay, smaller than 0.05. So this is in the critical region. So we need to go one more step to see if we included the 2, is it still in the critical region or not? So you can use the 0.0424 plus 12C2 0.35 square and 0.65 power 10. Okay, so you can use this plus 0.0424 plus the below this one, so you may get 0.1512. Okay, so 0.1512 is larger than 0.05. So means 2 is not longer in the critical region anymore, right? If this is not in the critical region anymore, means the critical region only including the last value is 1. Okay, so for the lower end, your critical region should be X smaller or equal to 1. Okay, so this is your critical region. So in this critical region will include X equal to 0 and X equal to 1. Only 2 things is inside the lower part of critical region. So just now we calculate 2. If you add one more 2, then it's out already. So 2 is not included in the lower critical region. So for the lower end, lower tails, this is your critical region, X smaller equal to 1. Okay, so this one halfway we done. Okay, how about at the upper part, upper tail? Okay, so at the upper tails, we have not calculated any value. So you need to calculate, you need to find by trial and error to find the critical region. So what is the value that you need to select? Depends on you. Okay, so you see at the first part you have 2 values inside the critical region. Mean at the end, if assume that this is a symmetrical binomial distributions, the first 2 should be in the last 2 should be in the critical region. So you may try larger values to how to say to find the critical region. You may test Px larger or equal to 10 and see what happens. Or you may try Px larger or equal to 9 and see what happens. Is it smaller than 0.05 or not? Smaller mean inside the critical region. Larger mean not inside. Okay, so in the exam normally they would give you a very many steps for you to try because if you give you too many steps to try, okay, you may lose a lot of time, right? So normally maybe you need 1-2 steps, okay, you were able to get the answer. Okay, so now this one I give you a hint. Let's see, we try from the larger value first, see what happens. Okay, let's say I don't know, I try Px larger equal to 8. I see what happens. Okay, so you can calculate this. 12C8, okay, 0.358 times 0.654 plus Px equals to 9 plus Px equals to 10 and plus Px equals to 11 and plus Px equals to 12. Okay, so by this calculation, you should get 0.0255. Okay, so this is smaller than 0.05, right? Okay, So if this is smaller than 0.05, mean Px equal to 8 still in the critical region. So you need to proceed one more step in order to confirm again what is the critical region. So you cannot stop at here, right? So one more step is you need to add in one more. We go for Px smaller or equal to 7. Okay, so then you can simplify x equal to 7 plus x larger equal to 8, that from previous part. Okay, that from previous part. So it's the step-by-step increment, right? Unless you are very lucky, you can guess where is it. Okay, so after you calculate this, you may get 0.084. Okay, so this is larger than 0.05 already. So means in this situation, okay, 7 is not longer in the critical region anymore. Okay, so means you can summarize as your critical region for the upper tails is x larger equal to 8. Okay, so from 8, 9, 10, 11, 12, all inside the critical region. Okay, 7 is not in the critical region. Okay, so for this question, your final answer should be, your critical region should be x smaller equal to 1 and x larger equal to 8. So this is your critical region, right? I hope that this one is clear for the binomial. Okay, so I will post the and question for you to solve. Okay, for the assignment. Okay, try to do the question and submit to the link. And next class we will go for discrete Poisson and also type 1, type 2 error. Alright, okay, thank you.